looking at how computers store information, how conversion take place, and all of that. So here we'll be learning bits and byte. So now, what I want you to understand, the foundation that I want you to understand is that every information stored on a computer, everything you see on a computer, they are represented in 0 or 1. In 0 or 1. Okay? In 0 or 1. So now, whenever you hear bits, is 0 or 1 is what is referred to as bits, meaning a bit can be 0 and can be 1, can be either 0 or 1. So that is why I include this table. I got this table somewhere on the internet. So now, for instance, if you press any key on your keyboard, computer see it as 0 or 1. Computer see it as 0 or 1. Is it as 0 or 1? If you press a letter M, capital letter M, computer will see it as 1001101. Okay? How this is done, leave it for computer to do the conversion. That is the language that it understands. That's the language that it understands. It doesn't understand your letter M that you are typing. It doesn't understand the movie you are watching. What computer understands is 0 and 1, can be 1110000. All those music that you are playing on your phone, on your laptop, computer see them as 100000. It is the one that is doing the conversion at the background for processing. Okay, so take note of that. So let's quickly see how information are stored on a computer. So now, I said bits are 0 or 1, right? So imagine we are having 0001100. It might not be easy to represent, okay, for we human when we are doing our interpretation. So now, instead of having a very long list of 0, 1, a very long list of bits. So now we now say let 4 bits equals 1 byte. Okay, let's 4 bits. Sorry, 8 bits. Sorry. 8 bits. 8 bits will be equals 1 byte. Okay, 8 bits to be equals 1 byte. So when you see 8 bits, you will know that it is 1 byte. That is why you normally see that your memory card can be 1 megabyte, 2 megabytes, or 1 gig memory card. Okay, so let me explain how I'm only giving you foundation of how computer operates information, so that in our next class you'll be able to understand better what we will be learning there. So now we said 8 bits, 8, 0 and 1, let it equals to 1 byte. Okay, so let's say 10,024 bits, let it equals to 1 kilobyte. Okay, so 10,024 kilobytes, let it equals 1 megabyte. Okay, bytes are represented in B, 1 megabyte. When you see small letter B, it means bits. Okay, so let's say 1024 megabytes equals, can you guess? Equals 1 gigabyte. Okay, so you can go on the internet to do your research. What do we have after gigabytes? So 10,024 gigabytes. What will it give us? Assignment for you. Okay, so these are just basics. So when they say an hard drive is a 500 gigabytes size, that means the amount of information that hard drive can store, that memory can store will be 500 gigabyte. That means 10101111 in 500 gigabytes places. Okay, in 500 gigabytes places. So have that foundation. You can do your research on the internet to have better understanding about this. I think in GSS2 or GSS3 or SS1, I can't remember the particular class in a secondary school when we were taught number based. So they normally taught us binary numbers in base 2. Okay, so they will say 10112001, that is in base 2. It means this number is in binary. Okay, the one that we humans are so familiar with, that we use in our everyday life, is a decimal. Decimal are number from 0 to 9. Okay, 0, 1, 2, 3, 4, down to 9. That is decimal number. Okay, that is what we are used to. Okay, that is what we are used to when we are doing our counting. Okay, and we have hexadecimal. This one is in decimal is in base 10. So I can, if I write 55 for instance, and I put 10, that means the decimal number, okay, is in base 10. So there is another, the third one is the hexadecimal. That one is in base 16. Base 16. So this hexadecimal, when we reach 0, when we have 0 to 9, instead of having 10, 11, 12 to 15, hexadecimal will now be A, B, C, D, E. 15 will be F. 15 will be F. So any number that you see, maybe in decimal or in hexadecimal, it has its equivalent. It has its equivalent to binary. Okay, if you just see letter 2, know that the binary equivalent is 0010. Okay, the same thing here. This is 1, this is 2. Okay, we can go back to our table to check. So now, this is 000. This is hexadecimal equivalent. Okay, you can pause the video and go through this table or do more research about this. So now, if you go to 15, 15 has its own equivalent. 15 in decimal, in binary is 1111. In hexadecimal is F. Okay, so These are just basic. These are just basics of how these are represented. So you can be asking, why am I teaching you all of this? Why am I teaching you? Are we in a mathematics class? We are here to learn networking. Why are you teaching us binary, decimal, and hexadecimal? The reason is our next class will be on addressing, how computer use addresses to locate one another. Okay, how they use addresses to communicate. Just the same way you have home address, computer too have their home address. For instance, if you know my house home address now, you'll be able to come to my house, right? If I know your home address as well, I'll be able to come to your house. So computers, they have addresses that they use. They have addresses that they use to locate one another. So the reason why I'm teaching you all of this is that when we are teaching addressing and you see, let's say 10, for instance, you'll be able to know the binary equivalence. Let's say this is in decimal, this is in base 10, decimal. You'll be able to know the binary equivalence, and you'll be able to know the hexadecimal equivalence. Okay, that's my goal. So that whenever you see a number while we are learning addressing, okay, maybe I write a number 192, for instance, and I say it is in a decimal. Okay, you'll be able to know the binary equivalent of it, how computer will see it in binary, maybe 0011, and you'll be able to know how computer will see it as an hexadecimal. Okay, maybe it is for instance BF3. Okay, this is just an example.